Hello, everybody. I'm already to click on that. Sorry. I'm a little stressed and confused right now. Okay, so we're going to start day 5 of Unit 4, which is talking about parent functions and the transformations of parent functions. So let's go ahead and get started. A family of functions is a group of functions with the same characteristics. So think about like the graphs of things. There are graphs of lines, which is one family. There are graphs of curves, or what we more specifically call parabolas, which is one family. There's graphs of lots of different shapes, which all fall in the same family. And those different shapes all have specific kinds of equations and stuff like that. So that's what a family of functions is. It's a group that all have those same characteristics. We're specifically going to focus on linear functions currently in this unit. So the family we're going to talk about is the linear family. I know it sounds so weird. The next one is a parent function of that specific family, so the parent of that family. And that's the function, that's the simplest function with these characteristics. So in a linear one, we're trying to find the most basic line, okay? And what these lines are what we're gonna talk about with the characteristics are what make up those lines. So the y-intercept, the slope, those are the characteristics that we're gonna look at. So for a linear parent function, that is actually the equation y equals x. Very, very basic. You have the y that you need, you have the x that you need. We still have a slope and a y-intercept in here, but it's like, it's the invisible numbers that we don't see. So the slope here is actually -1, and the y-intercept is a +0. So it's going to be a normal it's like a perfect diagonal line through the graph that crosses at the origin, and it's got a slope of 1. So it goes up 1 over 1, up 1 over 1 the entire time. So that's the parent function. Every other graph, every other linear equation that we deal with is based on this, where you have to have the y equal the x. So we might have stuff added to the end, we might have the x being multiplied, so it kind of it branches off from this, but this is the basic. Like, this is what you have to have for a linear function. That's why it's the parent. Okay? So here's the graph of the linear function. You guys go ahead and copy this down. It is the y equals x. This is what the graph looks like. So go ahead and draw this with your pencil or pen. Okay, and I told you at the beginning, I wrote on your note packet at least, that you will need colors for this, because I'm going to color code some things so you can kind of see differences. Okay, so after you drew this black line, which is your parent function, we're going to go ahead and graph the y equals -x. So we differed a little bit. We're venturing away from the parent. And we're going to change this to be a -1 for the slope. We're going to graph that in pink. So instead, we're still crossing the y-axis at 0, but instead of going up, we're going to go down 1 and over 1, down 1 over 1, down 1 over 1 to create this one. So the lines are very similar. They're still perfect diagonals. They're still perfect diagonals. They're still lines, but the difference is that while a parent function is a positive slope, this one's a negative, and this is actually a reflection of the parent function. So it got flipped, okay? And so, like, think of it, if you're like taking this one and you had a mirror image, it would actually be this one laying on top. It's kind of weird. It's the reflection of it, okay? So when you put a negative in front of that, when you have a negative slope, you are reflecting the parent function. And there's probably other things that's happening too, but it's a reflection of the parent function. Okay? And I know you're still working with the same graph, so you still have a pink line on yours. We're just going to keep working with it. So we already have the parent function graphed. It's in black. Now we're going to go ahead and graph the y equals x minus 3, so it's got a slope of 1 and y-intercept is -3. So I start at -3, go up 1 over 1. So I can create this line. And the graph of y equals, and we're going to graph y equals x plus 5. So same thing, same kind of slope, but a different y-intercept. Okay. How are the red and black lines different? Well, if I started at the black line, I actually moved down. All the points got moved down 3 units. So it went down 3 or -3. And the negative is telling us it went down. So you can either write -3, or you can write out the word, what that negative means, which is down. How are the blue and the black lines different? Well, all the points got shifted up 5 units. So it went up 5 units, or +5. So what we're noticing is that the number on the end is actually telling us how many units it got shifted, either up for a positive or down for a negative. So the y-intercept tells us about the shift, what's happening. So again, we graphed the parent function. So I think you guys have a new graph for this one. Please re-graph this line. And now we're going to graph y equals 1/2 x. So y-intercept is still 0, but we're going to go up 1 and then over 2. Okay, or down 1 and over 2. Just going to put us here. We graph that in yellow, and then we're going to graph y equals 4x in green. So start at 0, I'm going to go up 4 and over 1. Or I could go down 4 and over 1. Oh, that line's kind of funky. Funky monkey. Oh, well, pretend it's a straight line. We know it should be crossing right here. So, how are these different? The black and the yellow, well, black and yellow are still crossing at the same point, but the black is actually going up at a faster rate. It's steeper than our yellow line, okay? I would rather, if I had to run up one of these, I'd rather run up the yellow than the black, okay? So the yellow is less steep than the black one. How are the black and green different? Well, the green one is more steep than our parent function. So the only difference between the equations was the slopes. The parent function had a slope of 1, this one has a slope of 1/2, and this one has a slope of 4. So the slope, the number for the slope, actually tells us about the steepness. So the kinds of transformations you can have from the parent function are reflection, where the line flips, so it kind of creates a negative slope. Okay? A translation, where it's moved up or down, and that's looking at the y-intercept. If it's a positive y-intercept, it moves up that many units. If it's negative, it moves down that many units. And the last one is steepness. You can either, we can have a translation of being steeper or less steep. So if you look at the number part of the slope, not the sign, the number, the bigger the absolute value of the slope, which is talking about the number, not the sign, the steeper the line is. So if it's a bigger number than 1, it's going to be more steep. If it's less than 1, meaning it's a fraction, then it's less steep. Okay? So here I'm going to ask you to describe the transformation. So all we have to do is look at these equations. Okay? We don't have to worry about graphing it. We can tell just from the equations. Okay? So we're always comparing it to y. Woo! What happened? What's going on, guys? Y equals x. Okay. This is our parent function, y equals x. So we're comparing it to that. Now, this guy is negative compared to our parent function, which is not. So that negative sign means that we got a reflection. The next thing we want to look at is the slope. There's no number here, so it has the invisible 1. We're just looking at the number. So this has a 1. This also has an invisible 1. So it's actually the same steepness because they both have the same number. Okay? And then the y-intercept here is telling us how it got translated. Either got moved up or down. So it's +9. That +9 means it got moved up, and the 9 means it got moved up 9 units. So it moved up 9 units. That's all I have to write. I just need to go through, is there a reflection happening, yes or no? What kind of steepness is it? Is it steeper, less steep, or the same? And is there any translation? Did it move up or down, or did it not move at all? Okay? So that's what you're going to do with these two examples. One's in slope-intercept form, which is really easy because that's the form you need it in. The other one is in point-slope, so you will have to change this to slope-intercept form. Okay? Go ahead and give these two a try on your own. There we go. And we will talk about these more in class. We'll do some practice with it. I have the activity for you. And if you have any questions, write them down. We'll make sure we go over this stuff, okay? It's just those 3 things. That's all you need to do. Is there reflection, what's going on with steepness, and what's going on with the movement. Okay? Other than that, I will see you guys next time. And yeah, bye.